Hi everyone, welcome to Gnosis Learning.
My name is Parnika and I will be teaching you AP Computer Science Principle for this course. So let's see about this course. So basically what is AP Computer Science Principle? We will going to study about the five big ideas in this subject. The first one is creative development. Second is data. Third is algorithm and programming. Fourth is computer systems and networks. And the last one is impact of computing. So we will going to cover these five units in this subject. So first of all, I will tell you you can download our app from the Play Store apexams.us for AP Computer Science Principle. You need to download this app and so what is our program is about? Basically, you have to purchase our program. We will going to have our lecture every week, and around in 2 to 3 weeks, we will going to cover our one unit, depending on the how lengthy the unit is. And the lectures will be integrated according to your textbook course syllabus only. So we will going to have multiple choice questions and free response questions. We will going to assign you an assignment problem, like we will going to give you an assignment that will help you to prepare for your subject. And you can download our app, and in the app we will going to have the slides, the course structures, the book, and the questions, both multiple choice and free response. You will be having both types of questions there. Then we will going to give you the questions according to like Khan Academy problems and advanced placement problems. We will going to give you that you can solve. So let's see the test date for your subject. So computer science principal exam is on 8th May, that is Monday 2023. That is next year in May. We will going to have our exam at afternoon 12 p.m. So this is the timing for the exam. And for more details, you can go to this website apexams.us. It looks like this something. So you will going to find every subject over there like biology, calculus, physics, computer science. In computer science, you will find computer science AP principles. You can go there and search it and see the lectures timing about the course structure and everything you can find over there. So let's see the five main units. What is the weightage in the exam for these units? The first unit, creative development, it carries around 10 to 13% of weightage in the exam. The second unit, data, carries 17 to 22%. Third unit, carry algorithm and programming, is 30 to 35%. This is the most important unit we have, and it carries around 30 to 35 unit. The fourth one, computer systems and network, is around 11 to 15%, and the last one, impact of computing, 21 to 26%. Let's see in details. Like the first unit, creative development, it has four subunits: collaboration, program function and purpose, program design and development, and the last topic, identifying and correcting errors. So in this unit, we will study about these four topics. In Unit 2, we have binary numbers, data compression, extracting information from data, and using programs with data. We will have these four units, subunits in Unit 2, data. So in Unit 3, we have total 18 subunits as it is the most important and have the most of the weightage. So the first subunit is variables and assignment. We will study about the variables in it. Second one, data abstraction. Third, mathematical expressions. Fourth, strings. Fifth one, Boolean expressions. Sixth, conditionals. Seventh is nested conditionals. Eighth is iteration. Ninth, developing algorithms. 10th, list. 11th, binary search. 12th, calling procedures. 13th, developing procedures. 14th, libraries. And the 15th one is random values. 16th is stimulations, 17th is algorithmic efficiency, and 18th is undecidable problem. In undecidable problems, we will be covering all these subunit topics questions in that, and we will be studying about the programming in this unit basically. The fourth unit is computer system and networks. It has three subunits only: the internet, fault tolerance, and parallel and disturbed computing. You have already heard about these before, I guess. And the fifth one is impact of computing, which has six subunits. The first one, beneficial and harmful effects of computing. That what are the effects of the computing is both negative, positive. Second one is digital divide. Third is computing bias. Fourth is crowdsourcing. Fifth is legal and ethical concerns. And the sixth one is safe computing. So we will going to study about these six subunits in the unit 5. So what does the unit 1 says? Creative development. Basically in this we will going to understand the collaboration is crucial and developing computing innovations, because having a multiple perspectives offers opportunities to improve the design of innovations. In this big idea, the students will going to work about the collaboratively to design and develop the programs using a iterative development process. So basically in this we will going to study about the computing innovations, that what are the collaborations, how we deal with the computing, and what are the purpose of it. The second unit, data. In this we will going to study about the sample activities are the optional and offer to provide the possible ways to incorporate the instructional approaches into the classroom. So basically we will study about what is data is, and what are binaries number, how what is input, what is output, how we compress our data, how we extract information from the data from a code, how does it works. In the third unit, that is algorithm and programming, we will study about the all programming languages. So this is the most important unit, as I have said. And like all programming languages, like we have PHP, we have Java, and we have C. We have these three languages which we're going to study under this unit. We will see whether the language is block based or text based. We will see what are the structures, what is the syntax of a program, what are the commands, how we solve the problems. Like if we have any problem, how we will write the code of it. So basically it is about to how to abstraction from the language we can understand the programming languages. This big idea focuses on determining the efficiency of algorithm. So basically we will see that what is the efficiency of algorithm, how we write and implement algorithm in a program. How do we solve it? This is all about in this unit. Fourth unit is computer system and networks. We in this unit we will study about what are networks is, how we deal with the internet, what are the tolerance of it, and it will going to teach us what we have of computing. Like we have two types of computing, parallel and disturbed computing. The third subunit is all about it only, that what is computing and what is internet, how we deal with it. The fifth unit and the last unit is impact of computing, which says developing understanding. The creation of a computer programs can have extensive impacts. Some are unintended on societies, economics, and cultures. The basic idea for this unit is what are the responsibilities of a programmer and what are the effects of the internet and the computer is on our daily life. Like how does what is programming, basically how it is affecting our, how it is helping in developing, what are the pros and what are the cons of computing, we will going to study in this unit. The big idea can be integrated throughout the course and the works well with the creative development, data, computing systems, and network big ideas. And in this unit we will be studying these, as you can see, when using a computing innovations and transmitting information via internet, students should be aware of the risk of sharing personal identifiable information about themselves. So basically we will see that how internet is, what are the security which we should focus on that. So let me give you some basic idea for unit 1, that is unit 1 is computing basics. So let's see, I'll give you some introduction about this unit. So the first unit, computing basics, and the collaboration is our first topic. So basically what is collaboration is, a computer is a device, usually electronic, that stores and receives process and outputs information. Modern computing devices includes everything from a single sensor to mobile devices, tablets, desktop, servers, supercomputers, clusters consisting of multiple computers networked together. So basically, computer it's a device that usually electronic and that stores and receive and process and outputs the information. Like we put give some input to the computer and it process and it gives us the output information, the desired output that we want. So modern computing devices basically includes sensors, mobile devices, tablets, desktops. So we all use mobile, tablets, desktops these days. So it's all about that only. How does it work? So computer hardware usually refers to the physical components in a computing system, which includes input devices such as mouse, touchpad, keyboard, touchscreen. So input devices are that are connected to a PC, hardware devices that we use like keyboard, mouse, pen drive, and touchpad. These are all input devices. Hardware input devices. And what are the hardware output devices? That is monitor, like whatever we give an input from a keyboard, whatever we type from a keyboard, it is represented on the screen only. So that is the output device. We have storage device such as hard disk, solid state drives, as well as electronic components such as graphic cards. We have main memory, motherboards, chips that call a central processing unit CPU. We have a most important hardware unit, that is CPU. The full form of CPU is central processing unit, which is consist of graphic cards, main memory, motherboards, and chips, and etc. and many other items. So this is the like we have our bytes in which the our code is stored, basically megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, and yottabytes. So these are the bytes in the form of bytes only. Each and every function works in a computer. Like our first subtopic we will take as a flow chart. So what are flow charts basically? Sometimes processes are described using diagrams, which is known as flow chart. A flow chart is a visual representation of an algorithm or a process consisting of boxes or nodes connected by directed edges. Boxes can be represented as individual steps or a decision to be made. The edges establish an order of operation in a diagram. So basically, what is flow chart? We have like how do we represent an algorithm? We can represent it in a form of a flow chart also. Like we will have some boxes, we will make a tabular form of the nodes that, and we will write each and every step in that boxes, that how it works, what our program is executing, how we have executed it. It will be represented in a flow chart. Error handling. What is error handling? In general, errors are the potential conditions or situations that can reasonably be anticipated by a developer. So errors are basically whenever we write a code, so we have some errors in it, and obviously everyone have errors in their code. So whenever we write a code, we have some errors. So how do we handle it? How do we deal it? That is error handling only. For example, if we write a code to open and process a file, there are several things that could be go wrong. Like we write a code, we have write a code for opening and processing a file. Like you want to see an image, so you have write a code for opening and process that image file. So if something goes wrong, so what can happen? Like the file may not exist, it can show us, or we have not the permission for the system to read it, or the formatting in a file may be corrupted or not expected. It's in a like we have write a code only that it can only expect a JPG file, not a PNG file. So it can have that kind of error also. Still yet everything could be fine with the file, but it may contains errors and the invalid values if an error can be anticipated. We may be able to read and write the code that detects the particular error conditions and handle it by executing the code. So basically, when we have a code in it, when we compile our code, so we found an error. It is shown in the compiler that we have a code error in this line or in this line, and what is the error coming, we could identify it then. So it may be recovered from the error condition. We can recover it, we can correct it. Maybe it could be a syntax error, or maybe it could be a something else error that we have. We will see that in the further units. In the case of missing file, for example, we may be able to prompt the user for an alternative file. For example, if we have a file which is showing missing, so maybe there is some prompt which is like alternative file we have put in the input in our code, so it may show that the file does not exist. So these kind of error occurs. For example, you can see in the image, I can zoom it. So like this is some we have written some code and it is showing here written value error. The value error is coming here like in line 1, this is the error coming, or this is the, so value error, it is showing the iteration is not making a good progress as measured by improvement from the last 10 iterations. So like from the last 10 iterations, the code is in the Python only, it is in the Python language. So like it is showing that value error like this. More we have, so like more we have this error. For example, we have written this code and minimum value of some w, so it is written here hashtag error. It is the wrong syntax we have written. We will see the syntax how we write a code in the future units, but like you can see for an example, like we have used a wrong syntax over here, so it is showing a error over here. So this is all about error handling. So let's end this lecture, and you can download our app. You will find this app on the Play Store, and let's see you all in the next weekend for the lecture. Thank you.